Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be talking over Unit 3, Notes 6. So we're going to go over multiplying monomials times polynomials. So instead of just multiplying two monomials, we're actually going to be going into multiplying a monomial times a polynomial. So let's talk about what that looks like. So just remembering the rules of exponents, okay? So when you have a product of a power, which is what yours says, so you can ignore these and just kind of go off of what I say about your sheet. When you have a product of a power, you are going to add the exponents, okay? And when you have a power, I guess that those two are right. So when you have a power of a power, you're going to multiply the exponents. And lastly, zero exponents, remember, are always going to equal 1. Okay, so let's just go through kind of the step process of simplifying expressions. And so that's going to kind of be your box that says simplifying expressions. That's going to be that one right there. So just as a reminder of the distributive property, you do not have to write this down, but the distributive property lets you multiply a sum. And what you're going to do is you're going to multiply each term separately by what's on outside of the parentheses. You've done this before. Now we're just going to do it with letters involved. So here's kind of the step process you're going to go through for simplifying expressions. You're going to distribute the monomial into each of the terms in the parentheses. You're going to multiply each pair of the monomials by each other. You're going to combine like terms. And then finally, and probably most importantly, you need to make sure your final answer is in standard form. So you need your exponents going in descending order. Okay, so let's go ahead and let's take a look at number 1. So number 1, for starters, we're just going to take and we're going to distribute just like we always did in the past. So we're going to do negative 2 times 3. We're going to multiply those coefficients, and that's going to give us negative 6. X squared times x squared. When you multiply x squared times x squared, you're going to add the exponents, and that's going to give you x to the 4th. Then we're going to take negative 2 times negative 7. Well, negative 2 times negative 7 is going to give you a positive 14. And then x squared times x to the 1st. Remember, if there's no exponent there, then it's a 1. That's going to give us x to the 3rd. Okay, then finally, we're going to do negative 2 times 10, which is going to give me a negative 20. But I also need to remember to tack on that extra x squared at the end there. So even though it wasn't written, there was no x with the 10, there is an x with the 2 that needs to be considered when you're looking at number 1. Okay, so let's go ahead and let's take a look at number 2. We're going to distribute it in. Okay, 5 times negative 4 is negative 20. A squared times a squared, we're going to add those exponents, and that's going to give us a to the 4th. Okay, then we're going to do 5 times 2, which is 10. A squared times a to the 1st is going to be a cubed. Then you're going to do 5 times negative 7, which is a negative, oh, look at those boxes, a negative 35. And then again, we're going to tack that a squared on with it as it comes from the other one. So what we're going to do is now we have these going in descending order. So that means it's in standard form. So that's going to represent our final answer. So let's take a look at number 3 now. So for number 3, we're going to start by distributing in that 6y. And we're going to be multiplying it by each of the terms that follow. So 6 times 4 is going to give me 24. Y to the 1st, remember that's a y to the 1st. Y to the 1st times y squared is going to give me y cubed. 6 times a negative 9 is going to give me a negative 54. Y to the 1st times y to the 1st, you're going to add 1 plus 1, it's going to give you 2. 6 times a negative 7 is going to give me a negative 42. And again, I'm going to tack that y on. So I need to check, are my exponents going in descending order? They sure are. So that's my final answer for number 3. So let's take a look now at number 4. So for number 4, we're going to distribute in that negative 3x squared. So negative 3 times 4 is going to give me a negative 12. X to the 1st times x squared is going to give me x cubed. Okay. Negative 3 times negative 8 is a 24. Oh, that is a sloppy 2. Okay, so that's going to give me a 24, and it's positive because I multiplied a negative times a negative. X squared times x squared is going to give me x to the 4th. Lastly, negative 3 times 2 is going to give me a negative 6. And then that x squared is also going to be tacked on along with it. So now I notice that my exponents are not written in descending order, so I need to rewrite that so it's in standard form. So first I'm going to have 24x squared minus 12x cubed minus 6x squared. So that's my final answer for number 4. So now let's just talk about this briefly. We've already talked about this and you've already written it down. So I'm not going to go over it anymore, but it is there again in case you need to review it. Okay, so let's go ahead and let's move on to take a look at number 5. So for number 5, we're going to start by distributing in the 4. Okay, so 4 times 3 is going to be 12, and then d squared. 4 times 5 is going to be 20, and then d. So now notice that I'm going to only distribute that 4 into the parenthesis directly following. Same thing with the d. I'm only going to distribute it into the parenthesis directly following. So d to the first times d squared, that's going to give me minus d cubed. Negative d times negative 7d. First of all, that's going to become a positive, and then it's going to be d squared. Okay, and then negative d times 12d is going to end up being minus 12d. So I'm not done. It's not in standard form, especially because I do not have all of my like terms combined. So I'm going to start with my largest exponent, which is negative d cubed. Then I'm going to add 12d squared plus 7d squared, and that's going to give me 19d squared. So now once I've done d squared, now I need to look at my next one, so 10d minus 12d. Okay. Oh, this is a 20, not a 10. 20d minus 12d is going to give me plus 8d. So my exponents are in descending order and all of my like terms are combined. So that's my final answer for number 5. So now let's go ahead and let's take a look at number 6. So same thing for number 6. I need to start by distributing in my 3 and my negative x, only into the parentheses that follow. So 3 times 5 is 15x squared. Okay, 3 times 2 is going to give me 6x. 3 times a negative 4 is just going to give me negative 12. Now I'm going to keep adding this onto the bottom because I'm kind of running out of space here. So negative x times negative 7, or times positive 7x squared is going to give me negative 7x to the third when I add those exponents. Negative x times 2x is going to give me a negative 2x and then squared. Negative x times a negative 3, the two positives are going to become a negative. And so that's going to be plus 3x. So now, in order for us to get this in standard form, it needs to be written with the descending exponents. So first of all, negative 7x cubed. X cubed is my largest exponent, so that's going to come first. Next, I'm going to have 15x squared minus 2x squared, and that's going to give me 13x squared. And then I'm going to have 7x plus 3x, which is going to give me 9x. And last but not least, I'm going to have minus 12. So that right there is your final answer for number 6. So let's take a look now at number 7. So I'm going to start by distributing the 3 in here and the 6 in there. So 3 times 2 is 6, and then I get t squared. 3 times a negative 4 is a negative 12, and then I have t, that's a terrible 12. And then 3 times negative 15 is going to give me a negative 45. 6t times 5t, well, that's going to give me 30. And then t times t is going to be t squared. 6 times 2 is 12. And then we're just going to get the t. So now I need to write that in standard form. So I need to have my exponents going in descending order. So 6t squared plus 30t squared is going to give me 36t squared. And then I have negative 12t plus 12t. Well, those are actually going to cancel out. So I don't even have that left. And last but not least, I'm going to have minus 45 because there's no other term to add that to. So now that's in standard form. So that's my final answer. Now let's take a look at number 8. I'm going to take that x and distribute it in, and I'm going to take 2 and distribute it in. So x times 3x is going to be 3x squared, remember, because they're both raised to the first power. And then 4 times x is going to give me 4x. 2 times 7x is going to give me 14x. And 2 times a negative 3 is going to give me 6. Again, only multiplying into the parenthesis that follows. So then I'm going to have 3x squared And then 4x plus 14x is going to give me 18x. And then I'm going to have a minus 6, okay? So that's your final answer for number 8. All right, so let's take a look at this word problem in number 9. So in number 9, it says that Greg pays a fee of $20 per month for local calls. Long distance rate long distance is 6 cents per minute for in-state calls and 5 cents per minute for out-of-state calls. So he has a total of 300 minutes of long distance calls in January. M of those are going to be in-state calls. So now we need to write an expression. So that was a lot of information in one place. So we're trying to figure out what our total bill was going to be. Well, to start off with, we're paying $20 a month. No matter how many long distance calls we make, we have to pay that $20. So it says here that M represents in-state calls. Okay, so for every M in-state call I have, it's going to cost me 6 cents per minute, which I'm going to write as 0.06. Then, so that means that if M are in-state, whatever is left over has to be out of state. So let's say I told you that 20 of those minutes were in-state. So to get how many were out of state, you're going to take 300 minus 20 to get 280. Okay, so then for out-of-state calls, it's going to be 5 cents, and what we're going to do is we're going to take our total number of minutes, and we're going to subtract off how many we know are in-state calls, and what's left over is going to be our out-of-state calls. So I need to start by distributing in that 0.05. So I'm going to have plus 0.06m here. 0.05 times 300 is going to give me 15. 0.05 times the negative m is going to be negative 0.05 m. So now I need to combine those two. So 0.06 minus 0.05 is going to give me 0.01 m for my bill. Then that's also going to be, now I need to do 20 plus 15, which is going to give me 35. So this expression, the way it's set up, once you know how many minutes were in state, you can figure out what your total bill is, even if you don't want to calculate how many were out of state. All you have to do is plug in those in-state calls for M. So it makes it a lot less math once you solve out this equation. So let's take a look at number 10. So number 10 says a local parking garage charges $30 per month plus $50 per daytime hour and 25 cents per hour during the nights and weekends. Suppose Juana parks in the garage for 47 hours in January. Each of those are at night and during the weekends. So now we want to find her January bill. Well, first of all, she has to pay that that $30 no matter what. Okay, then we know she's spending each of those on nights and weekends. Now remember that it's 25 cents for nights and weekends. So we're going to take the number of hours that she spent in night and weekends and multiply it by the 25 cents. Then we don't know how many hours she spent during the day. Okay, but we do know it's 50 cents for the day. But what we do know is she spent 47 total hours. So to get the number of day hours, we're going to take the total number of hours and subtract the hours that were at night, which is represented by H. So now we're going to take that 0.5 and distribute it in. So I have 30 plus 0.25H, and then 47 times 0.5 is going to give me 23.5, and 0.5 times the negative H is going to give me negative 0.5H. So now I need to combine these two, 0.25H minus 0.5H. So that's going to give me a negative 0.25H plus 30, plus 23.5, which is going to give me 53.5. So once I know the hours that I've spent on the nights and weekends, I can plug that in and get the total bill, including the hours I spent during the day. Okay, so that concludes your note video for today. The word problems on the worksheet are really similar to these last two, so make sure you're using the note video to help you. Thanks for listening.